Lisa Dilling, and I'm an assistant professor at University of Colorado in environmental studies, which is an interdisciplinary program across all sorts of different disciplines at CU. And my work focuses really at the intersection between science and policy. I did my PhD in biology, and I studied the carbon cycle in the ocean. But then I got very interested in policy and how people use information. And what I study is how people use science in making decisions and how we can make science more useful for making decisions. So that's sort of more broadly. And then specifically I look at the area of climate change and how climate change science can be more useful for making policy and making decisions at all different levels too, for businesses and other things too. The carbon cycle is one of these big topics. People often talk about it in a sort of a global sense of the global carbon cycle. But really what scientists are really focusing in on now and interested in on now is how humans are affecting the carbon cycle. And what the carbon cycle is per se is how carbon moves between different pieces of the Earth's system. So how it moves from the land surface to the atmosphere, from the atmosphere to the oceans and back again. It's called a cycle because carbon goes between all these different reservoirs. And the thing that humans are doing to alter this is we are burning fossil fuels, which are, think of it as sort of compressed sunshine basically stored over many, many years in the form of coal and oil and so on. And it makes great energy for us, but the byproduct is it releases a lot of carbon extra to the atmosphere. So as that carbon builds up in the atmosphere, it's adding to climate change and making it warmer in the atmosphere and causing other impacts also. So basically people are concerned now about this extra carbon that's getting added to the atmosphere, where it's going, how it's going into plants, how it's going into the ocean, and then also how now the policy is turned more toward how we can do something about it as a society. Well, it can be kind of confusing, but basically they're talking about different forms of carbon that is all cycling through the Earth's system. When carbon's added to the atmosphere, when we talk about it in terms of burning fossil fuel, it's added in the form of carbon dioxide. So you can think about it as a carbon with a couple oxygens added to it. That's carbon dioxide. And it's a gas. It's a gas when it gets added to the atmosphere. But think about your trees in your backyard or your grass. Things like that are made of carbon, and they might be in a different form, obviously, than gas. It's a solid. Wood is a solid. So it's a little confusing, but think about it as just carbon can be in different forms. It can be in a gas form or it can be in a solid form, and it can move through these different reservoirs in these different forms. So it is a little bit confusing, but I think people don't really have to know that level of detail in order to think about what they can do about it. So yeah, there's several different techniques or tools people are talking about in terms of carbon sequestration. On the large scale, the kind of big industrial scale of carbon sequestration, people are talking about capturing CO2 when we burn, say, coal at a power plant for electricity, actually trying to capture it from that process and store it underground, maybe back in the reservoirs where we took out oil in the first place. And that way kind of keeping it from getting added to the atmosphere, so preventing it from adding to climate change. So that's one type of carbon sequestration on a very big kind of scale. But people are also talking about things like tilling practices for farmers. For example, no-till, which is a practice where instead of plowing the ground every year, you don't plow the ground between crops from year to year. You basically let your fields stay with the slash and the leftover material after you've harvested the crop, and you leave it there on the ground, and you don't plow up the soil. And because you aren't plowing up the soil, you're not releasing all this extra carbon to the atmosphere, which plowing can do that. So there's all different ways of thinking about carbon sequestration, but people are really talking, I think, a lot about the land-based ones in terms of agriculture, and forestry too. Trying to plant more trees is another technique people are talking about, because when you grow a tree, think about how a tree grows. It gets bigger and bigger and bigger, and as that trunk gets bigger, it's adding carbon into that trunk, and so you're keeping that carbon out of the atmosphere. And then even people talk about the ocean. They even talk about trying to put carbon into the ocean to keep it away from the atmosphere. And that can be also kind of big industrial processes on the most part, trying to inject carbon down into the ocean. So So scientists are working on this idea in lots of different ways. I think people are concerned about the possibility of leakage, say, from some of these underground reservoirs, but people have done calculations and calculated that it would be a very small amount, if any. But it's something that scientists are studying. I mean, it's definitely a research endeavor right now. It's not a proven technology that people are going out and doing right now. It's getting tried in Canada on a pretty large scale and in some other reservoirs, I think in Texas. But it's something in the research arena. And something else I think it's really important for people to know about the terrestrial side, sort of the land-based carbon sequestration, is it's not something that's on a very permanent type of scale. I mean, think about a forest. It grows for a while and it stores carbon over its lifetime, but that forest eventually can go up as a forest fire or can get used and harvested. The wood can get harvested and used in other ways, or it just gets old and dies, basically drops down. And so that carbon eventually does get released back to the atmosphere. So it's not quite the same as a permanent solution as maybe not burning the fossil fuel in the first place in terms of adding it to the atmosphere. But a lot of advocates have said too, though, that we need to consider all these options because we are in a state where climate change is happening, and so we need to be really considering all these different types of technologies and options to really do something, because the scale of the problem is so great. Well, I think clean coal it's not, again, my main area of expertise, but clean coal is the idea of trying to burn coal without adding the CO2 and the other compounds and negative things that we don't want to come out of the combustion process back to the atmosphere. So we already do some pollution control for when we burn coal. If you think about scrubbers for sulfur dioxide and mercury, and trying to keep some of these compounds from getting added to the atmosphere. And I think clean coal is really trying to burn coal at the temperature and with the technology in the power plant so that it can be as emissions free as possible. But you still need to deal with the carbon dioxide. It's still something that you'd have to put in something in addition to be able to have that truly be an emissions-free type of power source. And that would involve something like sequestration, taking that CO2 and injecting it down into the ground or otherwise storing it out of the atmosphere. So there's a lot of research going on right now. Actually, in Colorado, it's a really exciting collaboratory between several universities in Colorado and the National Renewable Energy Lab. It's a big collaboratory, they call it. And they're looking at different new types of fuels, biofuels, that could be used to produce energy, and biofuels being considered a renewable fuel. So when I mentioned that coal, for example, is stored energy for millions of years, something that's made from a biofuel is recyclable, basically, because you can regrow those plants or those algae on a shorter time scale and replenish that supply of fuel. So the new ideas that are coming down the pike are trying to consider things like cellulosic sources for ethanol. That's looking at things like switchgrass, which you'd think, well, switchgrass, that's not something we can eat or something, but it's actually a pretty environmentally friendly way of growing a fuel or a material that you can then turn into a fuel for cars. That might just be a little bit more friendly in terms of the energy balance of it than, say, something like corn ethanol. Corn ethanol has been shown to be it doesn't really always result in more energy coming out of it, and can be quite energy intensive to make. And people are also looking at even things like algae, growing algae, and trying to form energy from that. So there's a lot of exciting research, and people are really understanding that we need to consider all sorts of different factors when we're creating energy from these renewable sources. How does it impact other things that we're concerned about, like fertilizer use or water use, trying to make sure those things are all in balance as well. I think Colorado actually has a lot going for it in terms of positioning itself to respond to climate change. One of the things we have a lot is sun. We're out here on a beautiful sunny day. We have more sunny days than a lot of places in the United States, and so solar power makes a lot of sense for Colorado. Wind is also something that we have in abundance here. Both of those energy sources are carbon-free. They don't produce carbon dioxide. So I could see in the future that we really move towards looking at where those types of energy sources can be deployed in the best way. You know, where is there the most sun? Where is there the most wind? Trying to position ourselves in our grid and in the way that we hook up to our energy sources so that we can really think about distributed energy and what makes more sense in the locations, you know, specific around Colorado. So I think Colorado, and then of course the research on biofuels is, I think, going to pay off in that time frame you mentioned. So I would say that there's a lot of, we have a lot of different technologies at our disposal here that actually can really make Colorado a pretty green state in the end, of a state that really is responding to climate change and not having to use the old carbon-intensive technologies as much. I mean, obviously the first place to start is at home, and there are things you can do in terms of trying to insulate your house, and change your thermostat, make it more smart thermostat type of thing for setting temperatures. I think that there's a lot to be said, though, for the way we plan communities and the way we think about setting up our workplaces and our places we live and our transportation systems, thinking about this in the future. Colorado is still experiencing and will continue to experience a lot of growth. It's a really exciting place. There's a lot of jobs that are located here, and more will be located here. So it's going to be a growing population center, and we have to be smart about how we plan our growth, because there's a lot of energy that gets used in transporting people around to their jobs and to the supermarket, and in building our communities so that you can actually have a more walkable, bikeable, small-scale transportation system. You can do a lot in terms of climate change. Also, there's I think a lot of potential for things like the rapid transit that links the big population centers. If you want to live out in Boulder, for example, and work in Denver, being able to take that train system, it makes a big difference. And again, though, the trains right now run on coal, so we have to think about how can we move those systems perhaps to a less fossil fuel intensive type of energy. But also, if more people use them, then it becomes more efficient in general. But I think community planning is one of the big areas. Thinking about our fuel supplies and thinking about distributed energy, putting solar panels on people's roofs, having municipal power sources that are actually nearby, that are controlled and optimized for that particular area. It just makes a lot of sense because we have so many resources, and we have to think about our growth too. That's a natural phenomenon that's maybe getting a little bit exacerbated by climate change right now, and that's as I was mentioning, when you have a lot of carbon stored in the forests in the form of tree trunks and all the biomass of the forest, the leaves and the limbs and so forth. And when the pine beetle comes and it kills off that tree, it's still going to be standing there for a while, so the carbon's still locked up in that trunk for a while, but eventually it falls over, it starts to rot, and that carbon goes back to the atmosphere. So if you think about it, I mentioned the carbon cycle in the very beginning. Carbon is always cycling between the wood and the biomass on land and the atmosphere and the oceans, and it's kind of this constant cycle going back and forth between these different reservoirs. So when the pine beetle really is going to make a big impact in terms of our carbon cycle here in Colorado. It's going to be the cause of a lot of a release of carbon to the atmosphere. So now again, it's a natural cycle. When those forests eventually come back, when they start to regrow, then it'll be taking up carbon again from the atmosphere and storing that carbon in the trees as they grow. But right now, where we are in the cycle is that we are going to be losing that carbon to the atmosphere over the next couple of decades as those dead trees start to decompose and release the carbon back. Well, just as we're adding more carbon to the atmosphere, some of that carbon, that extra carbon, is getting absorbed into the oceans. And that process has been termed is changing the actual pH of the ocean, and it's called ocean acidification. There's a complicated chemical process. When that CO2 goes into the ocean, it gets transformed into different forms of carbon, but the bottom line is that it results in this gradual acidification, changing the pH of the ocean. And that is proposed, is hypothesized to have grave impact for some of the species living in the ocean, some of the algae, things like coral reefs especially are really in danger, because coral reefs form these skeletons that we see, these large kind of lumpy beautiful structures, but at the bottom of those coral reefs it's calcium carbonate, which is a form of carbon, and when you change the pH and you acidify the ocean, you start dissolving those structures, and you make it very hard for coral to form new structures in that pH. And so as we add more and more carbon to the atmosphere, and that carbon eventually goes into the ocean, that's an impact that we're going to be seeing increasingly, and it's not really much. There's not much we can do about it once that carbon's gotten into the ocean. So again, that's another reason why it's important to keep the carbon from going in the atmosphere, because then it will not. There won't be as much to go into the ocean and add to that ocean acidification effect. But it's not just the coral reefs, it's also plankton, which are small, tiny little creatures that float in the upper water column. They also, some of them form their shells and their structures out of calcium carbonate, and so as the pH changes, it's harder for them to do that. So, but again, there's research going on about how, we don't really know a lot actually about how the food web and how these ocean creatures are going to change or respond. But we do know the chemistry is pretty clear. We know that we're acidifying the ocean, and so the unknown is basically how the life forms in the ocean are going to be responding to that and affected by that. There's also, of course, in addition to the pH and the chemistry changing in the ocean, the temperature is changing in the ocean too. As the planet warms, the ocean temperature is warming as well. So there's some concern about how that's going to affect coral reefs and how that's going to affect other types of organisms that live at a certain temperature. But there's a lot of research going on, and we don't know for sure how that's going to pan out. Well, I think one of the things, and it's not just true for Coloradans, but it definitely could be relevant for Coloradans, is this is an issue that cuts across all ages, all types of people, whatever you believe in terms of politics and these kinds of things. It's really something that I think that the steps you can take to address climate change they cut across all these types of divisions, and they really are something that make a lot of sense for a lot of reasons. Nobody wants to waste energy. Nobody wants to be polluting the environment. Everybody would like to create jobs, and there's a lot of ideas that this is going to actually be a new energy economy. New energy technologies are coming forward. So I think, I'm an optimist. I hope that this can kind of unite people around this idea of moving forward. And there's people who still sometimes say, well, I don't know if I believe in climate change. I don't really know if I kind of accept that science stuff that people are saying. But the fact is, you don't even necessarily need to believe in climate change to believe that the solutions are something that we should be addressing and doing something about. It really, you look at the gas prices today and our dependence on Middle Eastern oil and so forth, and you think, well, gee, maybe we should be trying to develop other sources of energy that are closer to home, or that are renewable, that don't put us at risk in this global security sense. So I think that's something that I think is really a message I like to try to talk about, which is this is an issue that we can all find something that we can do in it. It doesn't necessarily mean you have to believe lock, stock, and barrel in every single aspect of the problem, but it does mean that you can find something that makes sense for lots of different reasons to do. And I think that's something that definitely is true for Colorado, because, again, we have such good resources here. We have solar energy, we have wind power, we're a growing economy in Colorado. We have a chance to really find a lot of new jobs, I think, in the economy from this type of new mindset, if you will, about energy and so on. We've moved beyond now the science debate about is it real, is it happening, this kind of thing. I think we're really in the debate now about what should we do about it. And there's a lot of different answers to that question. There really are. It's not clear that this one type of thing is going to solve it or this other type of thing is going to solve it. Policy there's a broad range of options out there, and they all have different trade-offs. As we've discussed with biofuels, you can have different trade-offs in water use and in the use of land for food and things like that if you're going to try to produce fuel. So those kinds of options and the trade-offs need to be discussed, I think, openly in public debate. And that's where our policy should really be going. It's not really anymore, I think, about science, yes or no, global warming, yes or no, is it really happening? Obviously, we still need to do science, and we still have a lot to learn in the scientific area. But I think in the policy arena, we can really move forward with some of these policies that make sense on a lot of different spheres for a lot of different reasons. So I think most people are thinking there will be a policy for global warming in the United States in the next administration, no matter who it is. So my project this summer is actually, I've been interviewing several farmers about whether they're considering carbon offsets, and that's an area that's just kind of new to Colorado. I think the farmers starting to think about whether they can participate in an offset program. But that's certainly something that's going to, I mean, individual farmers are going to be deciding for themselves whether they want to enroll their acres in an offset program. And for offsets, I mean, what offsets are is where if you do some additional practice on your land, like you say you switch to no-till, for a certain number of years, you can kind of calculate that you've stored a little bit of carbon in that land, and that can be offset against somebody who maybe is trying to reduce emissions elsewhere but hasn't got the technology yet to do so. And so those offset basically emissions elsewhere, and they can enroll in that through the Chicago Climate Exchange and so on. And so there are some farmers who are thinking about that, considering that, but it's not really yet in the big time, as you know, in Colorado, but it's.
And is there a financial incentive for them?
There is. There's a couple. It's a certain number of dollars per acre enrolled in the program, and it's not much money compared to some of the conservation programs and compared to what they might be able to get in terms of crops. But if it's something they're doing already and it's some practice that they're already engaged in, it could be something that would just add a little bit of extra money to their income stream. I spoke to a farmer out in eastern Colorado, actually, in the Mount Holyoke area near Sterling, and they actually have put most of their acreage now into conservation programs. They actually keep their acreage as forage for game birds and so on, and they've actually planted a lot of trees, and that's been part of the erosion mitigation program of the USDA, but it also has some implications for carbon sequestration. And for them it made a lot of sense because they loved the land, and they loved the living on the land, but they were concerned about the use of chemicals, they were concerned about other impacts on the environment in their particular area, and they felt like they could kind of make the trade-offs and get by on this kind of a plan for their land. And they're very proud of their trees and their conservation practices now, and they haven't tilled their land in a long time. They really keep it in no-till, and I think they would be. I don't think they've enrolled yet in the program, but I think they would be certainly amenable to that type of a program.